You think energy is a thing, a substance, a stuff that moves around, gets stored, gets used up. You imagine it like money, puts them in, takes them out. Always the same total. That picture feels solid, clean, safe. It is also wrong. You were taught to believe energy is conserved because it exists, because it is there, because nature is carefully keeping track. But nothing in your direct experience actually shows you energy itself. You never see it. You never touch it. You only see numbers stay the same. You think conservation means protection. That the universe guards energy like a sacred law. It does T. You think energy explains motion, explains heat, explains change. But what if energy explains none of that? What if conservation is? To a fact about reality, but a rule about how you describe it. What if you were taught the conclusion, not the reason? And what if the reason quietly destroys the picture you've been holding on to? You were taught to talk about energy as if it were a thing, something objects have, something that moves, something that gets stored and used. A battery is full of energy. Food contains energy. A moving car has kinetic energy. This way of speaking feels harmless. It feels natural. But it quietly plants a picture in your mind that never belonged there. You start imagining energy as a kind of invisible fluid, poured into objects, carried around, transferred from place to place. That picture is never stated explicitly. It does need to be. Language does the work for you. And once that picture is there, everything else feels obvious. Of course, energy must be conserved. Of course, the universe would let it leak away. Of course, there must be a cosmic rule keeping track. This is wrong, not slightly wrong, structurally wrong. Because no matter how carefully you look at the world, you never encounter energy itself. You see motion, you see temperature change, you see light, sound, pressure, deformation. You never see energy. There is no experiment where energy appears on a detector by itself. No instrument clicks because energy passed through. No photograph that captures energy in isolation. Every measurement labeled energy is a calculation, always after the fact, always inferred. You measure positions and speeds. You measure fields, frequencies, temperatures, then you compute a number and call it energy. That number behaves in a certain way. It stays the same across your calculations. And from that stability, the illusion begins. You mistake consistency for substance. You start believing that because the number does change. Something real must be staying intact underneath. But consider this. When you balance a checkbook, the numbers add up. Nothing in your house physically conserves money. There is no glowing substance flowing between rooms to enforce arithmetic. The conservation lives in the rules you chose to count by. Energy works the same way. That comparison should bother you. It should feel insulting because you were taught energy as physical, as one of the most real things in physics. Yet the moment you ask a dangerous question, where is it exactly, the picture collapses. You can point to a rock. You can point to a photon detector clicking. You can point to heat melting ice. You cannot point to energy. You can only point to situations and say, if I calculate this quantity here, and then calculate it again there, I get the same number. That sameness feels profound. So profound that you mistake it for ontology. But sameness is not existence. And here is the uncomfortable part you were never warned about. If energy were a thing, conservation would be a statement about reality. But it isn't. It is a statement about descriptions. And once you accept that, even for a moment, the entire foundation. You thought you were standing on starts to feel suspiciously thin. Once you let go of the idea that energy is a substance, something else quietly takes its place. A pattern. Not in the world, in your calculations. Every time physicists talk about energy being conserved, they are pointing to a stubborn numerical fact. And no matter how violently a system changes, collisions, explosions, melting, radiation, the final arithmetic keeps coming out the same. Add everything up before, add everything up after. The total refuses to budge. This feels like a deep truth about reality itself. It feels like the universe is enforcing a rule. But nothing is enforcing anything. There is no physical process that keeps energy constant. No mechanism that patrols interactions to make sure the books balance. The universe does not do accounting. You do. Energy conservation doesn't tell you why things happen. It tells you how to keep track of them without contradiction. That distinction matters more than you think. When a glass falls and shatters, you don't see energy splitting itself into pieces. You see motion turn into heat, sound, deformation. Only afterward do you assign numbers to each effect. The miracle isn't that energy stayed the same. The miracle is that your chosen way of counting didn't break. You could have counted differently. You could define a new quantity tomorrow, some clever combination of speed, mass, and position, and discover it also stays constant in certain situations. Would that make it a substance? Of course not. Yet energy gets special treatment because it works everywhere, from falling apples to nuclear reactions. That universality seduces you into thinking it must be real in the same way matter is real. But universality doesn't imply existence. It implies usefulness. Energy is a bookkeeping device that never fails, as long as you respect the rules that made it work in the first place. And those rules are always conditional. You must decide what counts as the system. You must decide what interactions you're including. You must decide what you're ignoring. Change those choices, and conservation can quietly disappear. This should unsettle, because conservation laws feel absolute, untouchable, sacred, yet they depend entirely on how you carve the world up. A system that appears to lose energy isn't misbehaving. You've just stopped accounting for something. That's not a flaw in reality. It is a limitation of your description. Energy conservation never guarantees stability. It never prevents chaos. It never protects order. It simply tells you that if your description respects certain conditions, your numbers will remain consistent over time. And consistency is not causation. Nothing moves because energy demands it. Nothing changes because energy flows. Those are stories you tell after the fact. The numbers stayed the same. So you gave it a name. And names once given start to feel like things. This is where most explanations stop, right at the edge of the real reason. Because the moment you ask why this number stays the same, not sometimes, but always, you were forced to look somewhere deeply uncomfortable. Not at objects, not at forces, at time itself. You were taught that energy conservation is a fundamental law, something the universe obeys, as if reality wakes up each moment and checks a rule book. But the truth is colder than that. Energy is conserved because time behaves a certain way, not the other way around. This is where intuition finally breaks. You imagine time as a background, a silent river flowing forward, the same everywhere always. That picture feels passive, harmless. It isn't T. Because if time were different, even slightly, energy would not be conserved. The conservation of energy is not a law about energy. It is a consequence of a symmetry, a simple one. If you run the same experiment today or tomorrow, the rules don't change. Drop a ball now. Drop it again later. The outcome depends on how you set it up, not on the date on the calendar. Physics does take care when something happens. Then indifference is the entire story. When the laws of physics don't change over time, a particular number you calculate stays constant. That number is what you call energy. Nothing deeper is hiding underneath. If the laws subtly drifted from moment to moment, energy conservation would quietly fail and nothing dramatic would break. Your calculations would simply stop lining up. This is the part that usually gets buried under equations because it sounds backwards. You want conservation to be the cause, symmetry to be a consequence. But it's the opposite. Time behaving the same way everywhere is the root. Energy conservation is the shadow it casts. And shadows aren't T objects. They don't push or pull. They don't T enforce anything. They appear automatically when the conditions are right. This means something deeply unsettling. Energy is not protected. It is not guarded. It is not kept. It emerges as a stable number only because time does T play favorites. And here, as the twist your intuition resists, the universe does know that time is symmetric. There is no awareness, no enforcement. Symmetry isn't a rule being followed. It is a pattern being observed. You notice that experiments dawn T care about the starting moment. So you build a description that reflects that indifference. Energy conservation lives inside that description, not inside the world. This also explains something that never quite made sense. Why energy can take infinitely many forms, yet always add up. Why it can vanish from one place and reappear somewhere completely unexpected. It's not moving, it is being reaccounted. You are not tracking a substance through time. You are tracking a number that exists, because time does de-interfere. And once you see this, the phrase, energy must be conserved, starts to sound naive. It's not a command. It's a consequence. A fragile one, because the moment time stops behaving the way you expect, the moment your assumptions about uniformity fail, energy conservation does T-protest. It simply evaporates. And physics allows that, which brings you to an uncomfortable realization. There are places where energy is not conserved, and the universe doesn't apologize. You were taught to treat energy conservation like a moral law, unbreakable, universal, absolute. So when you hear that energy might not be conserved somewhere, your instinct is to panic. Something must be wrong, the experiment, the theory, reality itself. But nothing is wrong. Energy conservation fails quietly, politely, and without consequence whenever the conditions that created it are no longer there. And the universe does not react. Consider a system that isn't isolated. Something interacting with an environment you chose not to track. Energy appears to vanish or appear from nowhere. But nothing mysterious happened. You simply stopped counting everything. That explanation feels too easy, so you resist it. You want conservation to be deeper than bookkeeping. But now push this discomfort further. Imagine a universe where the rules of physics change with time, not abruptly, just slightly. If experiments performed today behave differently tomorrow, even by an imperceptible amount, energy conservation has no reason to survive. And physics does not forbid this. There is no cosmic clause guaranteeing that time must be uniform forever. In such a universe, no substance is lost. No law is violated, only your expectation fails. Even closer to home, conservation depends on how you slice reality. You choose a system boundary. You choose a reference frame. You choose what counts as before and after. Those choices feel objective. They aren't. Energy conservation is not something you discover. It's something you earn by choosing descriptions that respect time symmetry. Change the description and conservation quietly dissolves. Nothing explodes. Nothing collapses. No alarm sound. This should bother you more than it does, because it means conservation is not a safety net under reality. It's a feature of certain perspectives. When physicists say energy is conserved, what they really mean is, under these assumptions, this number stays the same. Remove the assumptions, and the statement becomes meaningless. And here is the part that cuts deepest. Reality does not privilege your assumptions. It does take care whether your accounting works. It does take care whether your quantities behave nicely. Energy conservation is not a promise the universe makes to you. It is a pattern you notice when you are looking in the right way. And once you accept that, a dangerous question becomes unavoidable. If energy isn't a thing, if conservation isn't guaranteed, then what is energy actually measuring? Not metaphorically, not pedagogically, but structurally. Once the substance picture is gone, you are left with an uncomfortable void. If energy isn't a thing, then what is it? The mistake is assuming it must be something at all. Energy does live inside objects. It does flow between them. It does sit, waiting to be released. Energy is a comparison, always between states. Take any system, a rock, an atom, a field. You don't assign it an energy by looking at it. You assign energy by comparing one possible situation to another, higher, lower, before, after. Energy only exists in the difference. That's why absolute energy values don't matter. You can shift every energy in the universe by the same amount and nothing observable changes. That fact alone should have ended the substance illusion. Imagine discovering that you can add a constant amount of mass to everything and no experiment notices. You would immediately conclude mass is T what you think it is, but energy gets a free pass because it behaves like a potential. And potentials dawn, T describe objects. They describe relationships. Energy measures how systems respond to change, not what they are, but how they transform. This is why the same system can have different energies depending on how you describe it. Change your reference frame. Change your 0 point. Change what? You are comparing against the energy changes without anything physical happening. That should feel deeply unsettling. If energy were a real substance, it could behave this way. Substances don't depend on your perspective. They don't care where you set 0, but energy does. Energy isn't in the system. It is in the description of the system. And that is why conservation works the way it does. What stays constant isn't a thing moving through time. It is a relationship remaining consistent as time passes. Energy conservation is not about preservation. It is about coherence. The world behaves in such a way that your comparisons remain stable, as long as time behaves uniformly. Once you see energy this way, familiar phrases start to sound wrong. Energy isn't stored in a battery. The battery has different possible states, and the differences between them can be converted into other differences elsewhere. Energy isn't released in a reaction. The system transitions between configurations, and your accounting reflects that change. Nothing is flowing. Nothing is leaking. Only relations are shifting. And this is why energy feels both fundamental and slippery. It's not attached to any single object. It is attached to the structure of change itself, which raises an uncomfortable realization. If energy is a comparison, not a substance, then teaching it as a thing isn't just misleading. It is almost unavoidable, because the truth resists intuition. And that resistance explains why nearly everyone, students, professors, even physicists, struggle to talk about energy honestly. At this point, it's tempting to believe energy is taught wrong because teachers don't understand it. That is comforting. It lets you blame incompetence instead of structure. But the real reason is harder to accept. Energy is taught as a thing because the truth is almost impossible to hold in your head. From the very beginning, physics needs you to calculate, to predict, to solve problems. And comparisons don't feel concrete. Students don't grasp relationships, they grasp objects. So energy is dressed up as a substance, a fluid, a resource, something that can be stored, transferred, and used. This lie works. It gets you through homework. It builds intuition for engineering. It lets you design machines without philosophical paralysis. But it leaves a residue. You grow up thinking energy exists the way matter exists. And no one ever properly takes that picture away. Even physicists slip. They speak about energy flowing through circuits, radiating through space, leaking from systems, not because it's literally true, but because the alternative is painfully abstract. Feynman was unusually honest about this. He did try to replace the lie with a prettier metaphor. He removed the metaphor entirely. Energy, he said, is a number you calculate. It's not a mechanism. It doesn't explain motion. It summarizes it. That statement feels unsatisfying because you want causes, you want reasons. But energy is not a cause of anything. Objects don't move because they have energy. They have energy because of how they move. That reversal quietly destroys most everyday explanations, and it's why even experts hesitate to say it plainly. Once you admit energy isn't a thing, you lose a powerful storytelling tool. You can no longer say the universe runs on energy, or that life uses energy. Those phrases feel meaningful. They are in T. They are a shorthand for something much stranger, the consistency of relationships over time. Physics education keeps the lie because removing it too early collapses intuition without offering a replacement. But the lie becomes dangerous when it hardens. When you stop questioning it. When you start believing conservation is a cosmic safety feature rather than a descriptive pattern, because then you mistake the map for the territory. And the final chapter of this story is T about equations or experiments. It is about what it means to live in a universe that does T preserve things, only consistency. You were taught to believe the universe is held together by laws, firm, protective, unbreakable. Energy conservation feels like one of those pillars. A promise that nothing truly disappears, that there is order beneath the chaos. But that promise was never made. The universe does not preserve energy. It does not enforce conservation. It does not care whether your quantities behave nicely. What you call a law is not a command issued to reality. A pattern you notice when reality behaves consistently. Energy conservation does not hold the universe together. It reflects the fact that time, so far as we can tell, does not play tricks. And even that is not guaranteed. There is no deeper authority ensuring this symmetry must exist. No mechanism making sure tomorrow resembles today. The universe owes you nothing. This is the part that feels unsettling rather than enlightening, because it removes the sense of safety. If conservation is not enforced, then nothing is protected. No quantity is sacred. No rule is guaranteed beyond the conditions that create it. Reality does conserve things. It repeats itself, not perfectly, not forever, but enough for patterns to emerge. And from those patterns you build descriptions. From descriptions, laws. From laws, meaning. Energy is one of those meanings, not a substance, not a fuel, not a hidden currency of the cosmos, a shadow cast by time as indifference. When time behaves the same way from moment to moment, your comparisons remain coherent. When it does T, they one T. That all conservation ever was. And once you see this, the universe starts to feel less mechanical and more fragile. Not fragile in the sense of breaking. Fragile in the sense that nothing guarantees its regularity. The deepest order in physics is not enforcement. It is consistency. And consistency is not a thing you can touch. It's something you notice briefly while it lasts. That realization doesn't give you answers. It takes them away and leaves you with something stranger. A universe that doesn't save anything, doesn't guard anything, doesn't owe you balance, only patterns, and the silence underneath them.